Chapter 17, Chem 110B, exercises 17B and C have to do with Lewis dot structures for covalent molecules, which is the main part for Chapter 17 is about covalent molecules. There are specific steps you have to go through. It seems like it's a lot, but whenever you go through them individually and specifically, it takes very little time, and once you get the system down pat, it's really pretty easy. But you have to know these steps. For covalent compounds, we have to first count up all the valence or outer shell electrons, and you can tell based on the group A element that particular element is in. Second, we'll divide that number by 2 to get the number of electron pairs in the molecule, and all of them must be used. Okay? Next, draw the skeleton structure, how the atoms are connected. That's usually going to be presented for you. In general, the first atom is the central atom, except for hydrogen. And all the other atoms connect to that central atom. Then we place single bonds between the center atom and all the outer atoms. Then we fulfill the octets, which is 8 electrons for all the outer atoms. We want all the atoms in the molecule to be happy, and all these want to have octets, except of course for some of the exceptions. While helium won't be in a reaction, hydrogen be happy with 2 electrons, beryllium with 4, and boron with 6. These are the exceptions. We'll deal with hydrogen as an exception all the time. These two not so much. Okay, once you do that, get the skeleton structure, figure out how many pairs you need, and put single bonds between that center atom and all the outer atoms. Then any remaining electron pairs, if there's any left over, go on to the center atom. And then you have a decision to make. If all the atoms are happy with either 2 or 8 electrons, or satisfy their octets, you are done. That's the right Lewis dot structure. If not, you have to form double or triple bonds between the center and the outer atoms until everybody's happy. Because remember, you must use this exact number of electron pairs, no more, no less. And then finally, if there's a charge on the compound, you have to indicate it. Seems complicated, but it's not so bad when you get started here. Alright, so let's do one. Bromine. There's only 2 bromine atoms, each of which is for group 7A, right? Because bromine is in group 7A. If you're not sure, let's take a look. There's bromine 7A. So 7A means 7 electrons in the outer shell. So that's 14 electrons, valence electrons. Then we're going to divide by 2 to get 7 pairs. We have to use up every single pair and no more than 7. When there's 2 atoms, there really isn't any skeleton structure. Well, I mean, there's no central atom. Okay, pick either one to be your central atom. There's your skeleton. The Br is attached to the Br, of course. Then we put a single bond. There's the first one. Then we take care of the outer. 2, 3, 4. Notice that a line is equal to 2 electrons. So 1, 2, 3, 4 pairs. We're done with that one. We need 7 pairs. The rest go on this one. 5, 6, 7. Okay, all 7 pairs are used. We don't have any more. So now, are all the atoms happy? And remember, this is most important. All the electrons in the bond, in any bond, are equally shared by both of the atoms. So this bromine feels like it owns both electrons, and this bromine feels like it owns both electrons. So whenever you count, that's a total of 8, and that's a total of 8. So we're done. And Br, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons. That's it. Okay? Does that feel right? Does that feel okay? Okay, let's try H2S. H2S. Hydrogen, there's 2 of them, and there's 1 electron in the outer shell for hydrogen, right? There's hydrogen. 1A. The other element here is sulfur. Sulfur is in group 6A, so there's 6 electrons there. Okay? So we've got 2 electrons from those hydrogens, 6 electrons from that sulfur. Add them up, that's 8 divided by 2, that's 4 pairs. Hydrogen can never be in the middle, so the hydrogens are attached to the sulfur. That's the skeleton structure. We could also write it like an H down here, it doesn't matter. All we're trying to do is get the electrons spread around all the atoms so that everybody's happy. We'll deal with how they're connected later. Okay, that's the center. We're sticking single bonds between the center atom and all the outer atoms. Then we make the outer atoms happy. Well, they're already happy because hydrogen only wants 2. Can't have any more than 2. We need to use up 4 pairs, so the other 2 go here and here. Okay, so what's that total? 4 are all done. That hydrogen's happy, right, with 2. That hydrogen's happy with 2. And the sulfur feels like it owns these 2 and these 2. These are called bonding pairs because they're involved in bonding. And these are called non-bonding or lone pairs. Okay, because they don't get attached to any other atoms, so they're sort of all alone, just attached to the sulfur. So H, S, H, that's it. Okay? Alright, let's keep going. We've got a bunch more to go. I'm going to talk far less and just crank through. You can check to make sure that the counting is right at the end. I'm not going to circle them and draw them in. We'll just talk about it. Okay? You should hit pause right now and try to do all these, and it really shouldn't take you more than a couple of minutes. This is simple stuff. Just follow along. Okay? Hit pause. Come on back. Okay, I hope you gave it a try. Let's go. This is about real time. Alright, let's see how long this takes us. Alright, let's see, we've got carbon. That's 1 times 4 because it's in group 4A. Carbon, 4A. Fluorine, 7A. Okay. So there's 4 electrons from, outer shell electrons from the carbon. And 4 times 7, or 28 total valence electrons from the fluorines. So that's 32 electrons divided by 2 is 16 pairs. Oh my gosh, how are we going to get 16 pairs around everything here? Well, carbon is the center atom. The fluorines are attached. We stick 1, 2, 3, 4 single bonds between the center carbon and the outer atoms, and then we start to make the outer atoms happy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Alright, so what did we just find out? We used up all the atoms, we used up all the electrons, the outer shell electrons that we can use. Now, is everybody happy? 8, 2, 4, 6, and 8. Fluorine, 2, 4, 6, and 8. Fluorine, 2, 4, 6, and 8. Fluorine, 2, 4, 6, and 8. Okay, so we've got the outer atoms happy. What about that inner carbon? Well, remember, all the electrons in a bond are shared equally and by both atoms, so that both atoms feel like they own all those electrons. So that's 2, 4, 6, 8 that goes to carbon. We're done. That's the Lewis structure. That's it. Okay, next one. Phosphorus, 1 times 5. Why 5? Because phosphorus is in group 5A, so it has 5 electrons in its outer shell. We already decided that hydrogen has 1, but there's 3 of them. So that's 3. That's 8 electrons. Divided by 2 is 4 pairs. Okay, so how do things get connected this time? Phosphorus is in the center. The hydrogen's attached, and it doesn't matter where you stick them. Single bonds between the center atom and the atoms on the outside. Okay, we've got our single bonds. Hydrogens don't want any more. They are happy with 2. You need 4 pairs, so where does the extra electron pair go? Only one place it can go, on the center atom. Notice that the hydrogens are happy with 2, 2, and 2, and 2, 4, 6, 8 goes around the phosphorus. We're done. Next, see how quick this can go? Oxygen, 1 times 6. Hydrogen, 3 times 1. Well, that adds up to 9, doesn't it? 6, 3 is 9. And that's not divisible by 2, so something else must be going on. And it's the charge. What does the charge tell you? What does a +1 charge tell you? How does an ion get a +1? How did the sodium get a +1? It lost an electron. So we're losing 1 electron. Okay, losing 1 electron. So that's a total of 8. Divided by 2 is 4 pairs. 4 pairs again. Okay, so oxygen's in the middle. H, H, H. 2, 3 single bonds. Another one here. Look how similar this is and this is. Very similar. But we're not done yet. Even though the oxygen has 2, 4, 6, 8 electrons, and that hydrogen has 2, that hydrogen has 2, and that hydrogen has 2, what are we missing? An indication of the charge on the ion. Have to have it. Have to. Okay. Let's try sulfur dioxide. Sulfur, 1 times 6. Oxygen, 2 times 6. Everybody's in 6A. So that's 18. Divided by 2 is 9 pairs. So I'm going to stick the oxygens just like this because it's easier to fit in this little hole. It doesn't matter where it goes. We'll talk about that later whenever we start to deal with shapes. Because Lewis structure doesn't tell you anything about shape. All it tells you is where the electrons go. Alright, so single bonds. Oops. 1, 2. Now we have to get the outer atoms happy. 3, 4, 5, 6, 7, 8. And then we stick that last electron pair that we have left on the sulfur, 9. Okay, that's it. Well, let's count them up. That oxygen right there feels like it owns 2, 4, 6, 8, so that's happy. That oxygen feels like it owns 2, 4, 6, 8, and it's happy. What about that central sulfur? It feels like it owns 2, 4, 6. Sulfur isn't happy. We have to do something about that. What are we going to do? Well, you can't add an extra pair because then there's 9. Look, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've used them all up. So we have to rearrange these in order to make everybody happy. And you can't just take one from here and stick it over here because then this oxygen will only have 2, 4, 6. The only way is to make a double bond. Okay? So how do you end up making that double bond? You take one of the lone pairs on an outer atom and make it into a bonding pair. Okay? And it doesn't matter which one. Could have been any of them. Okay. So now let's count. Let's count again. That oxygen looks exactly the same as it did before. 2, 4, 6, 8, and it's happy. What about this oxygen? Well, check it out. 2, 4, 6, 8. As long as it stays around the oxygen, it's going to have 2, 4, 6, 8. It's going to be happy. And now let's look at this sulfur. 2, 4, 6, 8. That's it. Everybody's happy. And that is called a double bond. Alright, we've got 2 more to go. Let's go. Ever wonder why nitrate is a -1 and why sulfate is a -2? I'm going to show you. Okay, here we go. Nitrogen, 1 times 5, because it's in group 5A. Oxygen, 3 times 6, because it's in group 6A. That's 18. 19, 20, 21, 22, 23. We're forgetting about the charge. How many electrons is in the charge? And what does a -1 mean? It means well, if +1 means we lost an electron, right, that's an E. Then a -1 means we gained 1 electron. That's a total of 24. Or 12 pairs. So we have to arrange 12 pairs around these 4 atoms to make everybody happy. Nitrogen's in the middle. Single bonds. Take care of the outside. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's all we have. Notice that the nitrogen isn't happy. Those oxygens are definitely going to be happy. 8, 8, and 8. But the nitrogen only has 2, 4, 6. Doesn't matter which one, but somebody has to make a double bond. Now the nitrogen has 2, 4, 6, 8. And this oxygen has 2, 4, 6, 8. Everybody's happy. As long as you indicate that this is a -1 charge. Okay? So this is the only correct answer for nitrate. That -1 charge has to be there because that electron has to be added in order to get the right number of electrons around. Alright, 1 more to go. Sulfur, 1 times 6. Oxygen, 4 times 6. 6 times 4 is 24, and 1 times 6, that's 30, and the charge means we're adding 2 more, so that's 32 divided by 2 is 16 pairs. Right? 16 pairs. Sulfur. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Everybody's happy. 8, 8, 8, and 8, including those bonding electrons, and then the sulfur, 2, 4, 6, 8. Charge on the ion, -2, and we are done. That is Lewis dot structure, including charged species. Alright, give it a go, hack at it, The more examples you get, the faster you'll be. And remember, this is the first part to shapes of molecules, so you have to be good at it. Good luck.